Hello everyone, welcome to the video lecture series of Internet of Things. In today's lecture, we are going to discuss topic enabling technologies in IoT. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have studied logical design of IoT, Internet of Things communication model, Internet of Things communication API. Now let us discuss the enabling technologies in IoT. IoT systems are backed up by plenty of technology in the backend. Embedded system, wireless sensor network, communication protocol, cloud computing, big data analysis, security protocol, and architecture are few of them. These technologies handles hardware, software, and business intelligence perspective of an IoT application. Identification. IoT-based system has plenty of devices throughout the network, and important feature of these devices is that it has a unique identity and identifier that separate out individual things in a widespread network of the devices. This addressing capability provides the mean of communication endpoint to these devices. Various mechanisms are used for such identification like RFID, NFC, IPv4, IPv6, EPC global, etc. Maintaining these identities is a challenge in the IoT. Object Name Service, that is ONS, is a mechanism to find out information about a product and services from EPC, that is Electronic Product Code. ONS is a request that returns the list of all network accessible services related to the requested EPC. ONS takes EPC as an input parameter and provides address of EPCIS as an output in the form of URL. ONS doesn't contain the actual data of EPC but the address of the services where the actual data resides. ONS acts as a directory that routes the EPC information from requester to destination node. ONS system has root ONS and a local ONS. Root ONS keep the IP addresses of local ONS and local ONS keep the addresses of EPCIS. When the client sends the request with particular EPC as an input query, root ONS returns the IP address of local ONS where the EPC can be found. In next step, client send query to the local ONS which returns the IP address of the EPCIS to the client. The working of ONS is similar to DNS in networking. Figure shows the ONS and RFID communication. Now let us discuss wireless sensor network. Wireless sensor network. WSN consists of network of distributed sensor or collection of sensor that acts as nodes that collects actual data in the environment. WSN also has routers and coordinators. Routers help transfer the collected data from the coordinators for further processing. Once this data is collected, this data can further be transmitted to the internet where coordinators act as gateway. WSN provides self-organizing and self-configurable network, and along with this, the ability to provide environmental and physical condition monitoring using large number of low-powered and low-cost nodes makes WSN very useful. As WSN has large number of nodes, manual setup is very tedious task. Self-organizing capacity of WSN makes adding new nodes or removing old ones easier. ZigBee, which is based on IEEE 802.15.4, is one of the most popular protocol used by WSN. ZigBee works at 2.4 GHz frequency and provides data rate up to 250 kbps. ZigBee provides operational range of 10 meter to 100 meter based on the typical or environmental condition it is deployed under. Some example of WSN used in IoT system are: WSN is used to monitor soil moisture level in different regions of land in agriculture IoT systems. Indoor WSN checks air quality and level of various gases in the room's environment in indoor case study of home management IoT based systems. WSN helps collect data like temperature, humidity, pressure, etc. in the atmosphere to correctly deduce weather condition in weather monitoring system. Building maintenance system deploys WSN to check the pressure, vibrations in building, bridges, etc. Motion detectors deployed in WSN is frequently used in surveillance systems. Cloud computing. Cloud computing provides delivery of application services to the user over the internet. Cloud computing provides computing resources, networking and storage resources as per the user need. The resources delivery system is automated so that direct communication with the cloud service provider is not required. Services are provided on demand, obviously with payment for the required services. The services offered by cloud providers can be accessed over the internet via web applications using PCs, laptops, or using apps on handheld devices. In cloud-based environment, the storage or computing services are on shared basis, meaning the same hardware that is providing storage to one user is also providing storage resources to the other users. This is called as multi-tenant aspect of cloud. User access virtual resources on top of physical resources, because of which this multi-tenant aspect is not felt by the user while cloud is used. Form of cloud computing. First is infrastructure as a service, that is IaaS. Platform as a service, that is PaaS. Software as a service, that is SaaS. So the figure shows the forms of cloud computing. Infrastructure as a service, that is IaaS. IaaS provides computing and storage resources to the user as per their requirement. Computing and storage environment is provided in the virtual manner to the user. This storage space and computing resources such as RAM, processor power, etc. is managed by the user in the virtual space. The underlying implementation is managed by cloud service provider. User can install any OS and application as per need on this virtual space provided on the cloud. User can start, stop, manage and configure this space accordingly and will be charged as per use. Platform as a service, that is PaaS. In PaaS, cloud service provides application deployment tools, application programming interface, that is APIs, software libraries and all other services needed for complete application development. Cloud service provider, that is CSP, manages the underlying architecture like operating system, servers, networks and storage. User manage deploying, developing, configuring and maintaining the application developed over the cloud. Software as a service, that is SaaS. SaaS provides a full-fledged UI for service or complete software application to the user which they can use. Cloud service providers, that is CSP, manages the underlying architecture like operating system, server, network and storage along with application deployment and maintenance. The user only uses this software and is completely unaware of the cloud architecture. User can access such application via web browser from desktop, workstation, laptop, etc. and can also use apps on handheld devices if available. Characteristics of big data. Characteristics of big data. First is volume. Second is velocity. Variety. Let us discuss first volume. Big data is generally not threshold with particular amount of data, but the vast sized data which is difficult to manage, store, process and analyze using traditional database, and database processing tool is categorized as big data. For example, data generated through modern healthcare system, insurance company, IT industries, etc. requires big data assistance for storage and processing such huge data. Velocity. Velocity is the characteristic which generates big data. Velocity refers to how fast data is generated and how frequently it changes. Variety. Variety refers to the different form of data coming into for processing. Structure, unstructured data, text, image, audio, video, etc. formats have been managed by big data analytics. Some example of big data in IoT systems: sensor data generated by weather monitoring system, health and body related data generated by IoT based wearable devices or systems, retail audit and inventory management IoT system generates vast data, IoT based location monitoring system for vehicles, IoT based system deployed in an industry keeping track of various aspects like temperature, humidity, chemical levels in chemical industry, etc. Communication protocol. IoT-based system requires communication between the devices and the machine. This sending and receiving of data is processed through different level of networking. This protocol specifies addressing format for source and the destination, data encoding if any, routing of packets, connection mechanism for source and the destination, flow control mechanism, sequence control mechanism, etc. That makes the communication fluent as per the need. Embedded systems. Embedded systems form the basic devices for the IoT based system. Embedded system has a microcontroller or microprocessor at its core. Various kind of components like memory based component for ROM, RAM, along with networking, that is Ethernet, Wi-Fi, Bluetooth, storage, that is SD, eMMC, flash memory, and input output, that is display, mouse and keyboards units are grouped together with the central core. To coordinate all these components, embedded system run embedded operating system, which generally focuses on real-time task management. Summary of today's lecture. Today we have learned enabling technologies in IoT. Thank you.